Welcome to Retro 2 Fix, starring Dustin Morris, with your host, me, Jacob. Today, we're tackling a Nintendo Switch 2 that got wet and completely stopped taking a charge. Liquid got inside of it, built up corrosion on the board, which triggered a short circuit. We were able to clean up the corrosion, repair the short, and now we have it charging perfectly. For the test run, we're actually upgrading from our Meta 2 base to the full HD version. So if you like it, let us know in the comments below.
Okay, so we've got a pretty good one here. We got a Nintendo Switch 2, and the customer states that the system got wet, and now it kind of charges, but it doesn't. It charges up to about 8%, and then it just stops. And I've checked charging through both charging ports. Neither one of them seem to be charging. This is actually my first Nintendo Switch 2, so we're going to do the teardown and we're going to see if we can figure out what's wrong with this one. It's really difficult to even find any information about repairs on this online. You really can't find anything. So we're going to be kind of just trying to figure it out on our own, I guess, since we can't really find any information about what could be causing this. So first of all, we're going to get this thing apart and take a look inside and see if we can see any type of water damage or anything like that. This is even my first time taking this apart, so this ought to be an interesting repair. It's even difficult to find teardowns of this Switch, so it's really just not much information out there about it. I don't think enough of them have really broken for there to be a lot of repair videos, so hopefully we can figure this one out, and it'll be a good repair video that other people can use to try and figure out what's wrong with their Switch. So I did watch a couple teardown videos of this. I know that there's two tri-wings underneath the stand, and then there's two screws here on the bottom, and then up top we have one screw, and these are just standard Phillips, and then we have these little stickers on the side that have to come off. These look fun to try and get off, so let's see if we can figure out an easy way to kind of get under there and get the sticker out. That doesn't seem to get under there. Let's see, can we get under here? Okay, we're getting under it a little bit, but not getting enough leverage to get it out. Let's see if we can go for the corner here. I think these stickers are about the worst idea Nintendo's ever had. These things do not seem like they are easy to get out. And then once you get them out, are you even going to be able to get them back in? Let's see if maybe we can get something like this underneath there. Boy, these do not want to come out. Let's see, maybe we can get this in here. There we go. Try not to damage it as much as possible, but man. Poor design by Nintendo. Boy. It really does not want to come out of there. Okay, I want to kind of see if we can get just that lip up here. See if we can then get this underneath there. There we go. Okay, now we got something under it. So we can work our way to the edge here. Okay, there we go. Oh, shoot. Well, we had it. Let's see if we can do that again. Hopefully over time I get better at this. But right now this is not the easiest thing to do. Okay, back on it again. Down to this edge here. Okay, now we got it. Alrighty. Boy, what a terrible design. Not sure what they were thinking on this other than they just don't want these to be worked on. This does seem to work though. Unless the corner doesn't want to come up like that last one did. See if we can get lucky on this other corner here. Okay, there we go. I did that pretty good this time. Hopefully this corner will come up. It's not. Jeez. I am not a fan. If I can get this under there, it's a little bit easier. There we go. Really don't want to damage this thing. Let's see here. Get a hold of this. There we go. Alright. The reason why we have to take these two stickers off is because there are Phillips head on each side, and then also these little things right here are clips that hold on the back shell. So we have to pull off these two Phillips heads on each side. And then it looks like we have to engage these clips. Let's see, a tool for that. Around. Yeah, I don't see the tool I normally use for that, but let's see if we can get it with this. Let's see. Best side to grab it on, probably the top here. Let's see here. See, I think I've got both of those disengaged on this side. Let's see if we can get this in here and kind of get them apart. Just gotta probably get either the top or the bottom to pop off, and we should be good. Here comes the bottom. Once we get the bottom off, we need to make sure we get it over this charge port. So I'm just going to slide this in here and get it over the charge port, and then it should just pop right off. We may have to disengage the other side, maybe. I'm not sure. Yeah, it looks like you do still have to. So we'll go ahead and push these buttons here and disengage this side. Okay, there we go. Now, got the back piece off. All right, looking at this thing. Right off the bat, I don't see any corrosion anywhere from it getting wet. So let's go ahead and take off this back cover. Looks like there's quite a few screws here. I'm thinking maybe these screws right here will just take this piece off. So let's go ahead and start with that. And we'll set these to the side here. And should take off this antenna, I assume. The antenna is now free to come off. It looks like the antenna maybe just connects to those 2 points right there. Just pressure connections. Let's go ahead and disconnect the antennas as well. Looks like you're going to have to disconnect this white one from both sides and just pull the antenna off with the back piece here. Let's see, this looks like another antenna up here. Maybe just 2 screws on this one. This piece actually just stays attached, I think, to the whole thing. So we can pull off the black antenna now. That's under there pretty good. Okay. And then the gray antenna looks like it goes up here. And we can take that off. And I'm not sure if this is attached or not. Let's look and see. It is not attached. But it is attached to this circuit board right here, and it's actually hard soldered in, so we're going to have to probably pull this out here. Let's see if we can figure out how to kind of loop this out of here. Okay, there's that piece. Alright, I think maybe just get around there. Looks like it, yeah. Does this piece just pull up? Yep. Pulls right out of there. That's going to be fun to put back in. And let's see. Boy, that's kind of difficult to get out. It looks like it actually comes back this way. That's why. So I think it. Boy. That don't want to come. Let's see if when we get this whole thing loose, if that side gets a little bit easier. So let's take the remaining screws off of the back of this. Alright, so it looks like we got one there, one here, one here, one down here. Not sure what's going on down here. I'm not sure if we need to take this off or what. So let's kind of just move this thing and see if there's anything else holding it down. This antenna is going to come out with it. It does look like we probably got to take these 2 pieces out, and this looks like it's the SD card reader. So we got one screw there, and looks like there's a bracket right here that has to come off. See, yeah, the bracket comes off, and then the SD card reader should just unplug, it looks like, from here. It's in there pretty good though. Okay, there we go. Alright, that should be enough to get this off now. The SD card reader will probably come with it, because that piece of tape that's on there. Doesn't look like it's going to make this any easier. I was hoping we could, oh, there we go. Yeah, I was hoping we could pull that out so that we could just take this straight down and out. There we go. I think, oh, we forgot to disconnect the gray antenna here. So let's just go ahead and pull that out. Okay. All right, so we got everything out and we're down to the motherboard here. And this motherboard looks exactly like any other Switch motherboard, pretty much. I mean, unfortunately, the game reading slot is hard soldered in. That's kind of unfortunate. I guess that means that that's not going to be changeable very easy. But yeah, it looks pretty standard. You know, configuration looks about the same as all the other configurations. And as you can see from the glasses, we definitely see what our problem is. This right here is what's causing our issue. I think that is an inductor. It looks totally fried. We are going to put this under the microscope and see what we see with it. But just from the naked eye, that looks pretty bad. That is definitely where our problem lies. Oh, it actually is a cap that is blown. And possibly even this right here. That is a bad situation there. We are going to try and clean this up and see what kind of damage is done here. Because unfortunately, these parts are going to be very hard to come by. Normally, on a Switch, I would just pull off a part from a broken Switch that was not fixable, and I would just swap out this cap. In this situation, we don't have a broken Switch, so we are going to have to maybe do some research and see if we can find out what this cap size is. If it is actually what is blown here. I mean, it looks like it is totally destroyed. Let's see here. This is probably going to be very hard to fix. Let's get our meter out here and see if we can actually just see if this thing is shorting out. It could just be that cleaning it, you know, fixes the issue, because it could have just been a short caused by all the arcing and corrosion that we saw in there. Oops. Hopefully that's the case. If not, then, you know, we'll have to replace this component. But it does look very damaged, so I have a feeling that it's probably going to need to be replaced. Though it is not. Oh, maybe it's not shorted. But is this shorted? No. Okay. There's nothing shorted in here. I don't see anything shorted. Let's hit this with the brush and see if we can clean it up a little bit better. And then maybe we'll try and plug it in after it's all cleaned up, and we'll see if just this cleanup is what fixed it. I really would like to replace that component because of how much damage it looks like was done to it. But it's going to be hard to find. And if we can't find it and this one's working, we may just have to stick with it. It's about as clean as it's going to get. I really don't see any other problems on the board anywhere. Obviously we got some water damage on the, oh, there we go, there's a little bit right there. So we do see that obviously there was some water damage here. Let's see if we can clean up this area right here. I do see a little bit of corrosion up in here. So let's see if we can clean that. I do think I have one of those chips. I basically bought every chip you could possibly buy for this thing. Everything that was on sale from Mobile Centric. So if any of the chips were bad, I would be able to, you know, replace them. We did obviously get this more wet, but I mean it was already wet anyway, so there's not really much issue with getting it more wet. Let's see if anything is shorted out down here in this area now that we've cleaned everything up. I'm not getting anything. Should save one of these sides short of the ground. I'm not seeing anything. That's odd. Nothing there. And we're seeing. Yeah, let's move to here because we know that for sure is going to be grounded. It might just be that we didn't have a good ground there. Okay, that's grounded. Not grounded on this. Oh, grounded on this side and grounded on this side. So we absolutely have a short right here. Oh, maybe not. Oh, we were touching this. That's what it was. We were touching that. So we don't have a short here. We don't have a short here either. We were touching that housing a little bit. Okay. So no short there. Let's look and see just whatever else is visible here. See if there's anything else we can see that might have some water damage, and we'll try and clean that up too. We're still thinking in our heads though about where's that now? This cap right here. It looks pretty bad. This chip doesn't look great either. Let's see if I can grab a Q-tip here and try and clean that up a little bit, but it doesn't look great either. I don't know if I have a replacement for that or not. We'll have to look and see. There's no way we're going to find a schematic or anything for this, so we can actually test what kind of voltages and stuff we should have here. But let's see, everything looks good there. The issue we were having is we were actually not able to charge from either port. So, you know, it's something that controls both ports. We're not really sure what this circuit is, but this kind of looks like a power management chip to me, and it's right below that power management chip, so this would explain it, possibly why it's not working. So what we're going to try and do for right now is we are going to try and charge this thing and see what kind of current we are drawing when we charge it. So I'm just going to grab a cable over here and just plug it right here on top. It'll actually charge from both ports. So we're going to plug it in and we're going to see that we're getting 0.03, which would be probably pretty low for even, you know, if for like a slow charge, even if the battery was nearly dead. So let's go ahead and see if we got enough juice to turn this thing on. The speaker's trying to come out. It does show that it's charging, but it has always shown that it was charging. Okay, now we're up to 0.41. That is what I would like to see. That is definitely, you know, charging in the slow charge range. I'm not sure what these things charge fully, but I'm guessing it's probably over 1.5 amps. But a slow charge for these systems should be about 0.4 amps. Milliamps, sorry. Or 400 milliamps. So we're going to let this thing charge for a little bit, and we're going to see if it actually does charge past that 8% after we cleaned it up. And if it does, then we're probably going to call this good. If it doesn't, then we're going to have to investigate that area and probably see if we can figure out what size that cap is. So for right now, we're going to stop the video, and I'm going to let this charge for a while, and I will come back and I will let you know what happened. Okay, everybody, we are back now. We did clean up this entire area here with isopropyl alcohol, and we did find out that that is a 22UH inductor that was damaged, but it is testing good. You can test an inductor with your multimeter by putting it into continuity mode and basically just tapping both sides and making sure that there's a completed circuit through the inductor. So our inductor is testing good, and as you can see right now, we're pulling basically 800 milliamps and 12 watts. The maximum draw for the Nintendo Switch is 17 watts. So we are charging more than we were before, and when I turn the system on, it draws even more. I think it gets up to 17, yeah, 17 watts, which is the max. And then you can see that we are now at 19%. Previously, we were stopping at 8%. So I think maybe just all the corrosion in there caused the system to not work. It was just causing a short. So once we cleaned everything up, everything seems to be working fine with this system. So we are going to go ahead and clean it up and get it back to the customer. We really appreciate you watching our videos, and please like and subscribe if you find any of this information interesting or if you'd like to see more videos. Thank you. Bye.
And that's a wrap. Thank you for tuning in for another amazing showcase of Retro to Fix, produced by 1100 Productions. This is your host, Jacob, signing off. If you've got a broken system or console and you need a repair, reach out 561-320-7580. Remember, drop a like, hit subscribe, and we'll see you on the next one. Thanks, everybody. Good night.